okay? Good. Okay, welcome to DBI 307 Tips and Tricks for Building Rich Reports in SQL Server 2012 Reporting Services. This is a repeat session. I did the same session yesterday, but it was full, and they let me know that I guess a few more people wanted to see it, so they're repeating it today. It is a 300 level session, so it's not an introduction to reporting services. You should be familiar with reporting services at least at a basic level. You should be able to create a basic reporting services report, because what this session is about is we're going to show you how to create better and nicer reporting services reports and how to take advantage of some advanced features, and also maybe build up a little bit of really solid advanced knowledge about very important concepts in reporting services. My name is Ricardo Muti. I'm a program manager on the SQL Server Reporting Services team back in Redmond. And I focus on the engine at the core of reporting services, so the RDL file formats, the data extensions that connect to different types of data sources, everything having to do with data retrieval, data processing, processing of expressions, and rendering to different output formats, whether it's on the screen or exporting to different formats. So all of that. The objective today is I hope that when you leave this session, you'll be able to design reports, not just any reports, but reports that encourage immediate understanding and make the insights kind of pop off the screen. What I mean by that is that a good report shouldn't present the user with, a whole bunch of numbers and a whole bunch of data so that they have to go digging and searching for the values or the trends that really matter. Instead, what should happen is when they see the report, the values and the trends that are important and that capture some insight should just kind of leap off the screen at them and catch their attention. So the first thing we're going to look at is we're going to look at the tablix control. This is a really, really fundamental control in reporting services, and it's really useful for an advanced report designer to have a really deep understanding of the tablix control and how you use it to organize the data in your report in this sort of hierarchical grouped structure. Once you've structured your data and organized it and grouped it that way, we're going to look at how you can take a plain old table and how you can use colors and graphics and richer data visualizations within that table to emphasize the data. So like I said, that those insights really just pop off the screen instead of having to look at a bunch of numbers and figure out what's important. We're going to spend a lot of time on that point. This is going to be a very demo-heavy session, and I'll show you how to do all those tricks. We're going to spend a little bit of time on choosing the right visual. So some cases where you might consider two different visualizations, which one is better depending on the type of data or what you want to show. So just some guidance there. And finally, there's some miscellaneous tips and tricks that I have as well that I showed in yesterday's session. I was able to get through all of them yesterday, but there is a lot of content here. So I'll try and squeeze them all in again today. And we'll see how that goes. For today's demo, the sample data that I'm going to use is data on vineyards and the grape production across the United States. And I'm cheating a little bit here. It is real data. However, it's not about vineyards or grapes or wine or anything like that. It's actually about lettuce. It comes from the United States, the United States Department of Agriculture. And in North America, we showed this demo with lettuce. But I find that you can make more interesting things with grapes than you can with lettuce, so let's spice it up just a little bit. So first of all, let's take a deep dive into the tablix control. So what is the tablix? Well, I'm actually going to defer that question. We'll answer it more completely later. But the very basic case of a tablix is that it's just a table, right? Here's a typical table. You have rows and you have columns. There are two types of rows in this tablix. You have what we might call a static row. It's serving as the header row. And then you've got this thing, which is a row group. Unlike a static row, it's sort of we might refer to it as a dynamic row. So here you actually have one row in the report definition, in the template, and then it's simply repeated for each row that comes back in the query, right? Now, you could have a details table where basically the rows that you see here, which are down to the state level, are one-to-one with what comes back from the query in the data set. But we could also be doing additional grouping in the report so that there are actually a whole bunch of rows for, say, Arizona in the data set. And we're doing additional grouping, not in the query, but in the actual report. So it depends on what sort of grouping you have in your tablix. So let's jump into a demo. Here we go. I've got a data set here with all sorts of data on grape production. We've got a whole bunch of different fields for different states, different years, and then a bunch of metrics. Let's just insert a tablix. Now, you could use the tablix wizard, and definitely it is very handy a lot of times, but I want to show you how to create this from scratch so that we get a really deep understanding of how this works. So this is just a plain unbound tablix. What I'm going to do is I'm going to drag state in here, and then let's drag the production in here. And that's it. We'll just run it. Okay? So this might not have been what you expected because we get multiple values for each state. The reason is that the data set contains data for each state and each of 10 years in this decade. So that's why. We're getting 10 rows for each state for the 10 years in the decade. So let's just look at what sort of tablix we created here. If you look at this icon here, this sort of 3- icon, what that indicates is that we've got a details group. A details group is a particular type of row group where we're not doing additional grouping beyond what's done in the data set. We're simply showing one row in the visual table for each row in the actual data set. So, and down here in the row groups, you'll see that details group with the same icon. Right? So you have a details group. So you've got row groups and column groups. We don't have any column groups. Now, I mentioned static rows and dynamic rows or row groups in the presentation. One feature that a lot of reporting services users never discover because it's very well hidden is this advanced mode thing. And if you check this advanced mode, you will actually see not just the dynamic row and column groups, but you'll actually see the static rows as well, and static columns as well. So here you can see the header row, and you can see the 3 static columns. Okay. If you need to set any properties on these, which sometimes you do, if you want to build a report that uses page breaks, and maybe you want some columns or rows to repeat on each page, or you want to influence the behavior for when these things are kept on the same page versus flowed to a separate page, you can do that by setting properties on these column groups or on these row groups. So for example, when I select one of these members, you'll see in the properties window a bunch of things like repeat on new page or keep together, keep with group. But anyways, I won't go into that today because I'm not so interested in pagination today. We're going to be doing most of our work on the screen in just one page. So the other thing to note is this little bracket icon. Here it's highlighted in orange. That tells us what scope we're in for whatever cell is selected in the tablix. So here at this level, we're at the level of the details group. In this cell, we're still grouped by the details group. And this cell, same thing, because we only have the one group, the details group. So everything in here is in the details scope. Okay. Now, that wasn't what I wanted for it to be, to have all these rows duplicated. What I really want is just one row for each state. So rather than add the state the way I did, let's get rid of that column. And let's drag state down to the row groups instead. Okay. So now notice what happened here. This icon changed. I don't have just the 3 dashes anymore. I have this bracket thing around it that indicates that I've got a row group, a non-details row group, as well as having a details group inside of it. And I have 2 of these little bracket things, one of which is highlighted. So in here, I can see that I'm in the state scope. We're grouped down to the state level. But in here, I'm grouped down to the details level. And same thing here. You may also notice these dashed lines in between state and production. That is marking the boundary between different regions of the tablix. So on the right-hand side, we have the original body of the tablix, which is grouped down to the innermost level, in this case, the details level. And on the left-hand side, we've got the row group headers. So there's a header for the state row group. If I run this now, you'll see that I get one row group header for each state. But I'm still getting the individual years because I've still got that details group. I forgot to delete it. So if I delete that group, when I delete a group, it prompts me with a question. It says, do you want to delete the group and leave, and also any rows and columns related to that group? Well, if I do that, you're going to see what happens. It's going to get rid of the whole row because that's the row associated with the details group. That's not what I want it to do. So I'm going to undo that. The tablix structure is fine. I just don't want it to group by the details anymore. I just want to group by the state. So delete the group and say, leave the tablix alone, just delete the group only. Now if I run this, it looks correct, right? Wrong. It's not correct. There's a problem. The problem is that this production thing here, it's referring to the production field. I added that when I had a details group. And the problem is that it's not aggregated by anything. There's no aggregate function like sum or average or min or max or anything specified because we didn't need to specify it when we had a details group. There was only one value. But now we're aggregating 10 rows together, and we're not telling it how to aggregate those values. So what it does by default is it just takes the first one, which is wrong. We probably want this to be summed, right? So I'll sum it up. I'll just right-click and say summarize by sum. And then if I run it, I'll get larger values. And now it's correct. One additional thing that I want to do is I just want to format the number better. So I'll format this as a number. Get rid of a couple of decimal places. Run it. And now I should get some thousand separators to commas. So that looks better. I can add another group in here. So maybe I want to add year. I can just drag it in here, and I'll get a year group. Or I can drag it down to row groups as well. And now I've got an inner group for year. If I run that, now we've got, you're back to the level of grouping by state and by year. And the summarization still worked. I can add a total as well, or a subtotal. So for each state, I can go to the year, the inner group, and I can right-click and say add a total, either at the top or at the bottom of the inner group. I can do the same thing down here from the row groups. By default, it adds it to the bottom, so I'm just going to click that, and I'll get a total. If I run that, you can see now I got a subtotal for each state. So that's basically a simple table. But a tablix is more than a table. A tablix is a table plus the features of a matrix. Could be either. Now, if any of you have used SQL Server 2005 reporting services, you will know that we have a table control, a matrix control, and a list control. They're all separate. And if you choose one, you can't easily change it to another one later. You have to start from scratch. So that was the reason, at least the main reason, why we created the tablix control. Although it seems like you still have a table and a matrix and a list in the report builder and in the report designer, really under the covers, it's all the same control called a tablix. And it just depends whether you have row groups or column groups or both. So this way, it's easier to convert from one to the other. You can start with a table and end up with a matrix. So here's a simple matrix, right? I've got states on rows and columns on years. Some people also call this a crosstab. So I've still got a row and a static row and a row group, but now I also have not just this left column, but I've also got a column group or a dynamic column. Beautiful thing about the tablix control is that we can actually be more than just a table or just a matrix. It can be sort of a hybrid. We can have the column group from the matrix, but beside it we can also have some static columns like a table. So it's a very, very flexible control. So let's look at building a matrix as opposed to a table. And I can delete this, and I'm going to insert a matrix from scratch. And let's drag state on rows, year on columns, and production in data. Now, typically in a matrix, you're not going to have a details group. You're going to have a row and a column group, and the values in the intersection are going to be aggregated. It's generally a way of showing summary values. So you can see that by default, it already summed it, right? You can also see here, if I zoom in, that you're seeing these now, this sort of cross of 4 dashed lines. That's because we now have all 4 possible regions of a table, of a tablix, sorry. You've got the row group headers, the column group headers. They intersect to form the body of the tablix. And then you've got a corner in the top left corner. So those are the 4 regions of a tablix. And if I run this, I'm just going to make this bold, actually. If I run this, there we go. We've got the matrix. Now, what I can do here, one thing I want to show you, is that if I go back, I'm just going to undo and get back to that table that I had. If I didn't want to start from scratch, I could easily convert this to the matrix, even though they look quite different. So the first thing I'm going to do, first of all, I don't need this column. There's nothing in it. I'm going to delete it. This year column is no longer going to be a row group. I want it to be a column group. So I'm going to delete that. And yes, this time you can actually just get rid of the whole group and the column and everything. And then what I'm going to do is I'm going to drag year to column groups instead of row groups. Now this header is in a kind of a weird position. I'm going to just cut and paste it up here. And this inner header, I don't need to say that this is production values. The whole matrix is going to be production values, so I can get rid of that. And I don't need this subtotal either, so I'll get rid of that. And now I've got a matrix. Just make this bold again. Now we got the same matrix. It was a table, now it's a matrix. So now we can create one of those hybrid controls, right? I'm going to take, for example, we can do insert column and say outside of the group. This refers to the column group. So I don't want this column to be scoped for 1 year. I want it to be for all years. So that's why it's outside the group. And it's going to be to the left of this dynamic column. And then we can drag in the fields like I was showing before, but you can also use this little control. And I'm just going to pick, I want the number of acres of grapes planted. And I'm going to convert this, or just change the format, and run that. And now you've got that additional column beside a matrix. Got sort of a hybrid control now. Let's add another column. Let's drag in the number of acres harvested, because they don't harvest necessarily 100% of what they plant. But let's make it more interesting. Instead of just the amount harvested, let's make it the percentage that was planted that was harvested. To do that, I'm going to change this expression. And I'm just going to say, well, it's 1 divided by the other. It's the amount harvested divided by the amount that was planted. And you can see what that expression looks like there. Just one sum or one total divided by the other total, referring to 2 different fields. And I'll click OK. Because this is a percentage, I'm just going to format it as a percentage with 1 decimal place. I'll run that. And there you go. You can see that some states have a percentage that's quite high, including up to 100%, whereas other states like Michigan are under 80%, so there's some variation. Let's add another column. I don't need this one to be too big. Let's add another column. Let's add the production in here, just in between those two. But here we're going to do something interesting again. Let's say it's not the total amount of production. We want to know what this state's contribution is to the overall United States. So we're going to say the percent of total production. Here I need another expression. So it's going to be the production for the state divided by the production for all states. So one thing again divided by the other, so it's going to be divided by, but divided by what? It's the same field. It's still the production field, right? So what's different about the 2 things that we're dividing is not the field, it's the scope at which they're grouped. One is going to be the default scope because we're in the scope for a certain state. We need to break out of that scope and divide it by the overall tablix. So the way we can do that is we can specify the name of a scope to override the default scope. So here, I can break out, the tablix is called tablix1. I could give it a better name, but we'll just leave it at tablix1. And then here I can say, for the second instance of this production value, it's not the one for the current state that we're looking at or calculating. It's the production for the overall tablix. So you see in the second case, we've overridden the scope. So you're breaking out to a parent scope. And again, format that as a percentage. If I run that, now you'll see the percent of total. And you'll see that California produces 61% of grapes in the United States, Arizona 23%, and everything else is pretty insignificant. So there you go. We've created a matrix from a table, and then we've extended it to be a hybrid of a table and a matrix. That covers the first part of understanding tablix and building tables and building matrices. Now we want to make those tables and matrices a little less boring and make them really emphasize the important data. So here, for example, here's a boring table or hybrid table that we just created. Here's an example of how we could make it better. Right? So if you guys have been following the whole Metro design philosophy that Microsoft is embracing for Windows 8 and for Windows Phone and all these other products, it's really about getting rid of fluff and focusing on content and emphasizing the content. So by no fluff, for example, we're using just a thin, simple font here, right? We're not, we don't have a lot of bold or italics or weird colors going on, just a plain readable font. We're getting rid of lines. There aren't a lot of borders in this table because, honestly, they're arguably not necessary. Reports, if you look back at reports from 5, 10, 15 years ago, they tend to use a lot of the borders everywhere, the typical wireframe sort of table. And it adds a lot of clutter. And people started to realize, I guess, more recently, the trend is that if you use space effectively, you arguably don't need a lot of lines and borders between things. So this shows you an example of that. Dimming the labels. This has to do with emphasizing content. What people want to focus on is the actual data, not metadata that describes that data or just labels things or adds captions to things. So here, for example, the column headers, we want them to be less prominent, and we want the actual values that are more interesting to be more prominent. So we've dimmed those. And finally, if you're going to use an accent color to just spice up your report a little bit, the suggestion is use it sparingly. And the reason is not because color is bad. Color is great. It's very powerful. But we want to also use it for meaning. So, typically we'll use colors like green, yellow, and red to denote that something is good or something is bad or something is doing well or not doing so well. So maybe sticking to one other accent color, and ideally maybe even something that's not green, yellow, or red, maybe a blue or something else, will avoid us having too many clashing colors and having too much going on. Now, on top of that, let's say this harvested percent, okay? There are all these different values. We said there's some variation in the harvested percentage, but it'd be really easy to zero in on what's interesting if we had some rule. So maybe what's good, what's bad? Maybe we say that 95% and over is great, 90 to 95% is okay, and then under 90% is a problem. We could really focus our attention on what's important if we use an indicator like this, right, rather than just text. So when you have a rule like that, a business rule, use something like an indicator or use some conditional formatting to make that really pop out. It's best to stick with simple icons. There are a lot of indicators that you can choose with really elaborate icons. In practice, people have realized that the simpler ones tend to work best. So here we're just using a circle. I'll point out one exception to this, which is the accessibility issue. If you have users, and there's a good number of users out there who are partially or completely colorblind, they can't tell the difference between green, yellow, and red, then you may need to use a shape. But even then, try and do the minimal things so that these are easily distinguishable, but not going overboard with fancy icons. Instead of just having the color be either green or yellow or red, you can do a color scale, sort of like you have in Excel. Now, unfortunately, in Excel, this is easier to do than it is in reporting services because we don't have a feature built in for this yet. But there's a blog post here, and you'll get a copy of these slides, that tells you and has some custom code of how to do this. So you can do a continuous color gradient, and depending on what this value is, it's an interpolated color somewhere between green and red. So you're seeing some oranges in here, for example. The guidance here is you don't need a big area for this to be effective, right? Here I have a pretty small square, but it's good enough to get the point. So a lot of people would have tended to do something like this, and the argument is that it's probably not necessary, and the smaller one is better if that's sufficient. An exception to that, though, in a case where you may want to do this, is when you have this spread over a large area, including a two-dimensional area. So, for example, a heat map, right? Heat map is a really cool visualization, and you wouldn't want to see this as a bunch of hundreds of squares. So in that case, you may want to color a continuous area. Another option, of course, is you can just color the text itself. You got to worry about readability when you do this. But it is possible to do it well. The general rule is when you're coloring a fill, it can be a lighter shade, but when you're coloring text or lines, it should be a darker shade so that it's readable. And here's just a couple examples of things that shows up differently on different projectors, but there's usually not enough contrast for you to read that properly. So be a little bit careful when you're doing this with text. Now, one additional piece of clutter that we still have left is the matrix portion of this table. So you've got these years, and you've got all these numbers. What's the point? What are we really interested in here? So a very likely answer to that question is that we're really interested in, for each state, the trend. We're interested in how are they doing year over year? Are they producing more grapes? Are they producing less? So when you have a trend over time like that, really consider using something like a sparkline instead, right? This is a very dense way of showing pretty much the same information, and it immediately draws your eyes to the answers to your questions, right? California is actually producing more grapes gradually year over year. Connecticut is producing less grapes. So you can see the trend for each state a lot more easily than scanning all these numbers. You can still show the details if people want it. You can maybe hide it and have it expandable on demand. And you can still show a subtotal if you want to show the overall magnitudes, right? So remember, anytime you have time and you want to show a trend over time, and that's really what's most important, consider using the sparkline. As with like the point that I mentioned before, you might want to keep it to simple colors unless the color is really meaningful, right? You can make the details still expandable, like I showed. And whenever you use a data bar or a sparkline, the question comes up of should you align the axis or should you synchronize the axes? So here, the horizontal axis, the date range that this is over, is going to be synced by default. But the question is the vertical axis, the actual magnitudes. Should we synchronize that so that it's the same range across all the rows? By default, we don't. And the reason is that if you look at Arizona and California, they dwarf the other states so much that the other ones would become just flat lines and they would no longer be that useful. So we don't do that by default. And usually you don't want to do that, but you can. Here I'm showing a data bar. So data bar is a good way. We've added this yield column. Again, instead of just having text, it's useful to add a data bar here. And then you can more easily pick out the large values and the small values. You can also use color if you want, and using color in a meaningful way. It's kind of redundant with the length of the data bar, but it doesn't hurt. So you can have the large values, the states with a good yield and a nice healthy green, and the states with a poor yield, like Florida, with a not so healthy yellow. Again, the question of whether to align the axis, there's really only one axis when you have a data bar, and it's the value axis. And you definitely want to align it because otherwise you're just going to have all the data bars be the same length. So it's a little easier when you have a data bar. There's only one axis. Now here, when I have the percent of total, we've added a little sparkline that's actually not aligned. So sparkline, despite the name, is not necessarily a line chart. It could be a column chart. It could be a pie chart in this case. People will say great or horrible things about a pie chart depending on the conversation. It's a very controversial visualization, but a pretty good use of a pie chart is to show the contribution of something towards a whole or the progress towards a whole. So here we're showing, the contribution towards the overall United States. So it's a pretty acceptable use of a pie chart. Some people call these spark pies, but it's still a sparkline. Again, use simple colors unless the color is, you're putting it there for a reason and the color is meaningful. And I wish the product would have the pie chart start at 12 o'clock, straight up by default. And for whatever reason, it doesn't. So to get it to do that is one of the trickier tricks that I'm going to show you today. But that will really annoy some people if it doesn't start at 12 o'clock. Finally, the table is really good when you want to compare the rows against one another. You're comparing the sparklines or comparing the data bars against one another. But if your scenario is more that you're not so much comparing the states against one another, but you're actually just looking at each state mostly one at a time by itself and interested in looking at a list of things, you can actually get away from using a table sort of look and feel altogether and use something that looks more like a list, like this card layout. If you've seen any of the demos of PowerView, we have a visualization like this called a card in PowerView built right into the product. We don't have anything special for it in traditional reporting services, but the TableX control is flexible and you can create this if you want. So you can use a picture if you want. If you have a nice picture, it really adds to it. So for example, if you have a map of the state or the state flag or something, you can include that. It makes it nicer to work with. when you use a card, you typically want to use a butterfly style of alignment. What that means is that the labels here and the actual values are aligned right and then aligned left so that they kind of touch each other. And that just makes it easier to read. And then put some space between the cards so that you can see where one card starts and the other one ends. And I'll show you how to do that. And again, one accent color. So we're just using a blue accent color. There's not too much going on here. So now we're going to show you how to do all that stuff. So first thing I want to do is I want to make this report look nicer. Okay. And actually, before I do that, looks like when we set up the video, I lost something, which is just going to set my clear type to make these fonts look nicer. Okay. Now, move this down a bit and make this bigger. The Metro design style in like Windows 8 tends to use a couple of fonts, Sego UI and Sego UI Lite. It uses Sego UI Lite for headings when you have a big heading, and it looks kind of nice, so I'll make that 36 point. Then because we're dealing with grapes and I want to choose an accent color, I'm going to choose this indigo color. That looks kind of cool. And then for this, I'm going to use Sego UI as my main font of my report. I don't need this to be bold anymore. I also don't want any borders anymore, so I'm going to select everything and say no borders. And then I actually just want one border, which is for this whole thing. I want one border at the bottom. So I'll make it that same accent color, and I'll say put it only on the bottom. And then this, the actual text, I'm going to gray this out a little bit so that we emphasize the data. And then if I run this, let's see how it looks. So that looks a lot better, looks a lot nicer. So one of the first things was for the harvested percentage, we wanted to have an indicator for this. So let's add another column here. I'll insert a column to the right. I don't need it to be very big. I'm just going to put an indicator in there. And then right-click in the cell and say Insert. And this is a way of inserting a whole bunch of different data visualizations inside the cell of a tablix. And the one I'm going to choose here is Indicator. And again, lots of options. Just keep it simple. I'm going to choose this one. And then I need this expression because it's going to be bound to this same expression of the harvested percentage. So I'm going to copy that. And then I'm going to choose the indicator here. I'm going to get rid of the border on the indicator. I don't want the border. And then this, I'm going to bind the value of the indicator to an expression. And then I need to set the rules for the indicator. How is it going to decide what color? So I go to this values and states, and I say what percentage means. It's kind of deceiving in this case because the harvested percentage is a percentage. But what this means is percentage of the values that come back in the query. So rather than just doing the calculation or doing the rule based on the absolute values, it's going to do it based on where they fall in the distribution. It's not what I want. I just wanted to do it based on the actual harvested percentage value. So between, like I said, 0 and 0.9 is going to be red. Between 0.9 and 0.95 is going to be yellow. And between 0.95 and 1 is green. Then I'll just run this. Give it a sec. There we go. So we've got our indicator. Now, if I didn't want to do the indicator and I want to do the color scale instead, I'm going to delete the indicator. And what I need is, I'm just going to use a rectangle. There's a control called a rectangle that will just allow you to draw a rectangle and change its fill. So I'm going to insert a rectangle in the tablix cell. And then I need a rectangle inside of that because I want it to be smaller. So I'm just going to insert a rectangle here. I'm going to make this fairly small. Let's zoom in a little bit. So I want this to go inside the other tablix cell. So make it smaller. And then I'm just going to drop it in there. And I'm going to hold down Control and then use the arrow keys to really fine grain move it around. And then I need to set the fill color for this. And that's where it gets a little tricky because this is the feature that I said was not built into the product, right? So I need some custom code to do that color scale. So this is the one that I said, if you get the slides later and go to the blog post, you'll find all this code. But I'm just going to grab the code. And now I need to put it in my report. The way I do that is you just click anywhere behind the page here in the empty space and you say Report Properties. And then you go to Code, and you can paste in your VB.NET code. This code also refers to some stuff that's in system.drawing in the .NET framework. So it's got a handy code comment here that I need to add a reference to this .NET assembly. The way I add a reference is with references. So I go to References, I say Add, and you add the fully qualified name of the .NET assembly. So now I've got that code, and the expression that I need is here. And if I go on the rectangle properties, it's got a fill. The fill can be a color, but it can also be an expression. Anytime you see FX, that means you got an expression editor. You can set that property to an expression. If I paste it in, if I zoom in on that, you see that we're just calling code dot and then the name of our custom VB.NET function, which is called color scale RYG, red, yellow, green. And then just passing in the value and saying, determine the value of the scale of the color between, given that the value is between 0.8 and 0.1, so 80% and 100%. And we'll run that. And now you've got a color scale. Yeah. I'm going to get rid of that. The last thing I'm going to do with the colors is I'm just going to color the text. So, again, I need this expression. Sorry. I'm going to just say text box properties, the font, and then I can choose the font color, but I'm going to use this FX thing. And then the expression, I've got it saved here. These are just custom code functions. So I'm going to paste that in. And you can see the expression there just says color scale 3, because I want to override the default red, yellow, green, and I want to make them darker. So I'm going to use red, orange, and green. Now the interesting thing about this is you can see where it says me.value. I didn't have to pass in the expression, duplicate the expression for the actual value in the text box, because when you're using a text box, me, if you're familiar with VB, refers to the current object, which is the text box. It's like this in C#. So me.value is the text box's current value. So you can just say that without having to duplicate the whole expression. And then if I run that, it should get colored text. There we go. Great. So next thing I wanted to do was I wanted to replace all this year stuff with a sparkline. So let's right-click here, say Insert Column outside of the group to the left. And then in here, I don't need this to be that big. Let's say Insert Sparkline. And then I'm going to use an area. Typically, you want, for this sort of thing over time, you want to use a line chart or an area chart. I'll use an area chart. And then I'm going to get rid of the border on this thing. And the category group here is the x-axis. That's going to be the year, because it's going to be over time. And then the value is going to be the production. And then I'm going to set some properties on the series. I want to change the border so that it's a dark gray, and the fill so that it's a light gray. And then I'll run this. And now we got a sparkline, so you can see the trend. So now I want to hide these years. I want to hide them by default. So I'm going to call this trend. And then the year, I'm going to insert a row up here and say outside of the group above. And I'm going to put a, well, I don't want that border there. Let's get rid of that. I'm going to put a text box in here that's going to act as a toggle, and I'm going to call it Show Details. And I'm going to give this text box, I'll go to text box properties and give it a better name, because by default it just gets a not very good name like text box 38. Let's call it Show Details Text Box. You'll see why I'm doing this in a sec. Now I'm going to go to this year, which is a column group. So let's go down to the column group and say this is what I want to hide and what I want to toggle. So go to Group Properties, go to the Visibility, and say instead of showing it by default, hide it by default. But let it be toggled by this other report item. Now I have to refer to the thing that's going to be the toggle. And that's why I wanted a good name for it. So pick Show Details text box. And one more thing I want to do is, since this year thing is going to be collapsed, when it's collapsed, let's at least show a subtotal or something. So I'll do insert column to the right. Oh, sorry. Insert column outside of the group to the right. And let's call this average production. And in here, I'll pick the production. But by default, as a sum, I'm going to say summarize by average instead. And then finally, I want to just merge these cells at the top. So just click Merge. So it says Show Details. Now I'll run that. And there we go. So the years are hidden, but I see the average production. Oh, I forgot to format the number. Let's format the number. Check that. Say number. Okay, so average production, we can see the trend. If we really, really want to see the details, they're still there. I can click that and get the details. Okay. So the next thing I wanted to do is I wanted to have the other Spark line, which is actually Spark Pi. So I'm going to insert a column to the right to put my Spark Pi beside % of total. And here I'm going to say insert a Spark line. But this time we're going to pick a shape. We're going to pick a pie chart. And I don't want a border on this. I always have to get rid of the borders. And I need this expression. I need the expression that calculated for me the % of total. So I'm going to copy that. And then going back to my pie chart, I'm going to say that the first value in the pie chart is that expression. So I'll paste that in. Here it's got a category group. What's my category group? Well, the category group would be, the values of a field that would give me each slice of the pie. But I really don't have some field that's going to be the slices of the pie. The slices of the pie are the % of total and the rest of it that makes it add up to 100%. So I'm actually going to get rid of a category chart altogether, or category group altogether. Oops. What I really need is whatever is going to make this pie chart add up to 100%. So I'll add another series, and I'll say 1 minus the other expression. So those are going to add up to 100%. And then now I'll just set the formatting on those slices. I want the border to be dark gray for both. But the relevant part of the pie, I want it to be colored gray. The other one, the border is still going to be dark gray, but the fill is going to be white. So the part that's a little bit grayish is going to be the contribution to the total. Okay, I'll run that. There you go. But you can see the problem that I mentioned, which is that it likes to start at 3 o'clock instead of 12 o'clock. So this one isn't pretty, but it can be done. So if I check this, this is one of the few parts of this demo where I need the properties pane. It's not available in any dialog or anything. It's a really, really buried custom property. So I need to go down to custom attributes. There's a whole bunch of custom attributes for the chart. And there's one called pi start angle. Okay, and by default it's 0. It considers 0 to be 3 o'clock. So to make it 12 o'clock, I'm going to say, no, make it 270 degrees. And now, let's get rid of the properties pane. If I run this, now it's at least at 12 o'clock. So that looks more correct. Okay. The last thing that I wanted to show was the data bar. So I'm going to add a column here for the yield. Let's just bring that in. And then this is a text box. What I want to do is have the data bar below it. So let's say insert row inside of the group below. It's still going to be grouped by state, so it needs to be below. And then here I'll say insert data bar. And then this will be bound to the yield that we just added. Same thing as the text box above it. They're both bound to the same field. I'll make this tiny. It just needs to be a little sliver. And then we'll run it. Well, it worked, except that it's not a sliver. It's this thicker thing that I wanted. Also, it looks like I got the green coloring coming through on the yield. So let me get rid of that. I don't want this to be green. I just want it to be black. And let's format the number the way we want. And this thing looks like it still has a border on it, so we'll get rid of that. Let's run it. Yeah, so that data bar is still thicker than it's supposed to be according to the way I designed my report. And this is a feature of reporting services. The technical term for this feature is that it's a bug. And what's worse is that I realized I had to track down where this bug is and who owns this part of the product because we got to get this fixed. And that backfired because it ended up being me. So I'll have to follow up and see if we can get that fixed. But in the meanwhile, I really like this trick. I like this sort of visualization. So I wanted to at least, you're going to hit it if you try it. So I wanted to at least let you know how to get around it. So what we can do is whenever we want to add multiple things inside of a cell in a tablix, we just insert a rectangle. Instead of using a text box, which can't really nest other controls as the cell contents, use a rectangle as the cell contents, and then put other things inside that rectangle. So the rectangle acts as sort of a container. So let's move this text box out of the way for a sec. I'm going to make this bigger. And then here, we'll insert a rectangle. So insert a rectangle. Now our cell contents is a rectangle, and that can act as a container. We can put the other things inside it. So let's take this text box, move it inside that rectangle. And we're going to take the data bar and move that. Got to make it a little bit bigger so it's easier. Move that inside the rectangle as well, just below the text box. Now I can make that smaller. Sorry, let me make this. There we go. Okay, let's move that inside. And now we can make this row smaller. And I don't need this row at all anymore. Okay, so what we just did is now we have a rectangle inside the tablix cell that contains both a text box and a data bar. And when I do that, the bug doesn't reproduce anymore. So one problem here is normally the data bars would be aligned left to right in a left to right language, but anytime we have numbers, they're typically right aligned. The reason that they're right aligned is so that we can see the place values line up. But here, we're going to use the data bar to compare the magnitudes anyways, so that's not really necessary. And it might look nicer if we left align this instead. Let's see. Yeah, so I think that looks nicer. It doesn't matter that the place values don't align because we're going to compare the data bars anyways. Okay. So I think that covered everything. Hope I didn't forget anything. We used a whole bunch of different visualizations, and it's a much nicer looking table. So going on to the next section, choosing the right visual, right? So just to recap what we just did, we had a plain old table, plain old hybrid table matrix. And it was, you look at this table and nothing really jumps out at you. You have to start scanning the values and scanning the numbers and comparing the numbers to figure out what's important here, what we're supposed to be learning from this. Instead, we converted to this, where immediately stuff jumps out at you, like, oh, California has a very high % harvested. And Florida has a very low one. California, great yield. Colorado, great yield. Florida, poor yield. California, Arizona, they produce most of the grapes, right? And then you can see the trend. So it looks like Connecticut doesn't want to produce grapes anymore. So this stuff just jumps out at you. Now, some people, depending on your taste, you may find is overkill to have too many of these. You don't necessarily want to use every trick that I'm showing you today in the same report, but I want you to know what they all are so that you can use them to your discretion. So here's a little quick quiz. Let's say that we had a chart where we wanted to graph the production of each type of grape. Which would be better? Should we use a column chart or should we use a line chart? Well, when we have categories, these are just categories. It's not a quantitative axis. It's just a categorical axis, right? it's really hard to come up with a reason why we should be joining a line that suggests a sequence between these categories. So really, this one on the right does not make sense, right? How is Cabernet linked to Merlot, or how do those form a sequence? They don't. It's not a scale. So for categories, typically use bars or columns. On the other hand, when you do have a logical sequence between things, or you have a quantitative axis, you can use columns. I mean, here it's not as bad as the inverse scenario. And one case where you actually might want to use columns is if you actually bucket these years into like decades or something. Then you essentially convert them to categories, right? Because each one is a category of a bunch of years. And then you can use columns, and you're creating essentially what's a histogram. But otherwise, when you have a series or a sequence of values, or you have a sequence of numeric values, you have a numeric axis, typically a line chart or an area chart would be better than categories. So this is the better choice in this case. Here you have a line chart which has got a bunch of lines in it, and it's really busy. It gets hard to read when you get over a certain number of lines. The colors start, not having enough differentiation, and they just jumble into one another. And you have to ask yourself, what's the point of this visualization? If the point of the visualization is to compare the absolute magnitudes of these different states, then it's probably not the best visualization, because there's a bunch of extra information in here. Whereas if the point is to compare the trend, or look at the trend for each one of the states, it's still not ideal, because they're all jumbled up with one another. So if we really wanted to look at the trend, which is probably the case here, for each state, we might be better off using a table or a list with a bunch of spark lines. Right? So you can see the thing on the right does a better job if we just want to know the trend for each of the states. So consider spark lines instead of series when you just want to know the trend for each of the lines. Finally, if you want to show correlation, right, maybe you want to see how the yield compares to the percent harvested and whether those two have a correlation, you can use a column chart like the thing on the right, and you're essentially going to be looking then for when are the columns of a similar height versus a very different height. But generally, the best thing for checking for correlation is a scatter chart. See the scatter chart here. You can see that it's got a moderate correlation because the things are somewhat aligned diagonally. But what really pops out at you is, look at Hawaii, this gray dot here. That's a real outlier. So it's just that much better in presenting correlation or lack of correlation. So when you have correlation, consider using a scatter chart. Finally, more tricks, and it looks like we got some time to go through them, so hopefully we'll get through all of them. One of them is adding clipboard data. So let's imagine that I found some other data on the web or something, and I just wanted to get it into my report somehow. It's not a large volume of data or anything like that. Do I really have to stuff it into a relational database somewhere or put it in a cube somewhere and then query that? Can't I just add it to my report? Well, it's not that easy. It's sort of an advanced trick. We really want to make this scenario easier going forward because this is increasing in popularity as a scenario. And you can see some of the newer stuff like we're doing with Power View. If you're using Power Pivot, you can just paste the stuff into an Excel worksheet, sync it into the Power Pivot model, and now it's a data source, and now you can query it. So with the traditional stuff, if you're not using a Power Pivot model, it's not quite as easy, but there is a way of doing it. Integrating related data, we got requests for this a lot, and we added some simple features here, some programmatic features, for you to be able to take data from two different data sets and use it in the same visualization. Displaying short lists, it's really best that I show that by example so you understand what it is. And then finally, optimizing for output to Excel. So firstly, clipboard data. Right? I have a bunch of data. Let's say that I found some data on the web on the amount of sunshine that different states get. And I want to pull that in and check it against the data for production of grapes. How do I get that into my report? Right. One way is I can use the XML data extension. So we have to look for a data extension or a data source type that allows us to put the values right in the command text, right in the query. And you could construct a bunch of SQL statements with a union that would do that, but maybe a better one might be the XML data extension, which has a mode of querying where you actually just put the XML document right inside the query, and that's what it uses for the data. So the problem that we're left with then is we need to convert this table of stuff that we pasted in Excel or wherever flat file and get it into a set of XML elements. We can actually use Excel to do that. So basically use a bunch of Excel formulas to construct XML attributes and XML elements, and then we've got an XML document that we can paste right in the report, right in the query. So let's show you how to do that. Here, this is what I got from the web. So there's some page that shows this percentage of possible sunshine for each of the states. By pasting that into Excel, it looks like this. It's not properly, delimited as columns. But if you go in Excel and use this data feature called text to columns, it will actually help you parse a flat file. Whether it's CSV or whether it's delimited by some character or whether it's fixed width, you can parse a flat file and get it as columns. And then you got something like this. And then I can convert that to an Excel table. You just say format it as a table. And then eventually you got something like this. And now we can use Excel formulas and Excel table references to construct an XML attribute. So for example, the first attribute I want is state equals, and then the state code. Right? So the way I can do that is I can build an Excel formula and say concatenate. And then I could just type state like this, because I know it's called state, but if I want to be even more robust, I can just refer to the table header caption. And I can say table 5, headers, and the header for state is what I want. And then I need a equal sign and a quote. And then I need the value of the state, so I can say just table 5 state. And then I need the close quote. As you can see, it's sort of a complex Excel formula, but it's basically just the header equals and then the value. If I click OK, that's what it created. So it created my XML attribute name value pair. By doing the same thing for the sunshine percentage and then taking those two attributes and making them an element, doesn't matter what the element is called here, I'm just calling it X. As long as I refer to it correctly in the report, it's fine. We've got a bunch of XML elements. So then I can just take those, copy the whole thing, and now I've got a list of XML elements. Now in my report, I'm going to close this report. I've got a data source, an XML data source. And the XML data source has a few different modes. It can retrieve an XML document from the web, so this could be a URL. It could call a web service. But I'm not doing either of those. I'm doing the third one, which is it's just going to have an embedded XML document. And in that case, you don't need any connection string. It's all in the query. So here's the sunshine data that uses that XML data source. And there's some boilerplate XML query stuff that you need in here that I've put in there already. But here I can just paste within this root element thing all those XML elements that I want in line. And then up here at the top, where it says the element path, I got to tell it which elements or attributes I want in my data set. So here I want the state, and I want the sunshine percentage. By default, everything comes in as a string. We don't know what the data types are, so I'm going to override the sunshine percentage to say that it's not a string, it's a decimal. Just zoom in on that so you can see. So I'm just pulling in the two attributes and overriding the data type of one of them. You can actually check this in the query designer. If I just run it, you'll see it in tabular form. That's what it got back. So that looks okay. And then I can just put state and sunshine data in my table and run it. And there you go. State and sunshine data from data embedded right in the report. So like I said, we want to make this easier, but that's how you can do it today. Related data. So if you're lucky and you're building a report, to make things easier on you, maybe everything is in one data source. It's in one SQL Server relational database or in one cube or something. But in some cases, you have other data that you need to pull in. Now, maybe if it's another relational database, you can do link servers or something like that. But it might not be a database at all. It could be a file, it could be a cube, could be on the clipboard like I just showed, could be from the cloud, could be OData or something. You can't join these things at the data source level. So you've got to join it in the report. So, and if you want to show them in different data regions, that's fine. That's easy. But if you want to show them in the same data region, like you want to pull in the yield for each state, as well as the sunshine percentage, which is in a different data region, and group them on some common field, you have to do a lookup from one data set to the other. This didn't used to be possible before SQL Server 2008 R2, but we added some basic lookup functions. Again, it's still sort of an advanced programmatic thing to do, but you can do it now. So use a function called lookup. The way lookup works is you specify a matching field. You say, what's the field in this data set, which is a state? What's the field reference in the other data set, which would also be some field with the state names? And what's the field you want to get back, which is the sunshine percentage? And then finally, the data set name is the name of the other data set where you want to look up that return field. So, I'll show you how to do that. Here, we've got a scatter chart. But this data point here, its y value is mapped to the yield. I want to check the yield for correlation against the sunshine percentage. Sunshine percentage is in a different data set, so this is not bound to anything. The x value is not bound to anything. If I run it, you're going to see that the y value is plotted correctly, but the x value is missing. It's not bound. So to bind it, I need to bind it to an expression. Let's just open this up. I'm going to bind this x value to an expression, and I need to do a lookup. So I'm going to look up, and then the name of the field in this data set, which is the production data set, is called state. Oh, no, sorry, it's called code.value. In the other data set, it's called state.value. The field that I want to get back is called sunshine percentage. And then the name of the other data set where we need to do that lookup is called just sunshine. Okay? The two matching fields, the one I want back, and the name of the other data set. Now when I run this, I get the correct scatter chart. So you have a scatter chart that's pulling in data from two different data sets. Join is happening in the report. Short lists. What I mean by short lists is, let's say you have something like regions and states in the United States, and you don't necessarily need one row for each of these states. You just want to list the states that are in that region so people know what Midwest means or they know what Northeast means. We just want to do these as maybe a nice comma-separated list or something like that, and we don't have too many values that makes that impractical. How can you get multiple rows in the report or in the data set and join them together in this sort of comma-separated fashion? The way you can do that is with a combination of two functions. One is called lookup set. So lookup set is analogous to lookup, except that instead of returning one value from the other data set where you're doing the lookup, you're returning all the values where that match succeeded. So now we've got a set of values that was returned from the lookup set. Then you take the join function, which takes in a set of values, and then builds them into one string using whatever delimiter you pass in. So we could pass in a comma, for example. We could do sorting, or we could do distinct sorting if your data is not already sorted in custom code, but let's assume that they're sorted. Okay. So to do that, let's pull up short lists. Okay, so here, you'll see that I have region and I have state code. I want this comma separated. So I'm just going to make this bigger. I don't want this additional group anymore, this details group. So let's get rid of the group, because I only want one row. And then I'm going to have to change this expression. Let's open up my data set again. So you've got region and state code. I'm going to get rid of this. First, I need to get the set of states that are in that region. So I'm going to do lookup set. This is going to be interesting because I'm going to do a lookup to myself. There's only one data set here. So I'm going to say lookup the region, and you're going to match against itself, which is the region. So you're doing a self-join and matching on region, and then saying get back the state code. And the name of the data set is called state regions. That gives me the set of values, and then to join them together, I just say join, and join with a comma and a space between you. Then I'll just run that. And there we go. Comma separated list. Finally, output to Excel. No matter what you do in your report, people may want to export it to Excel and maybe bypass everything you did. So there's a couple of flavors of export to Excel. We could mean just doing a data dump, which is really export to CSV to be more accurate. And then you're opening it up in Excel and parsing the CSV. When you export something like what we built before to CSV, by default, you're going to get something awful like this. The reason is that it's outputting everything. It's outputting not just the text boxes that you're seeing, but all of the raw data that drives the indicators, the data bars, the spark lines, all the grouping, so that you can redo your analysis in Excel. But really, that gets quite ugly. So you can take control of what is output and what's not output to any sort of data render, not just CSV, but also XML and Atom as well. So the other thing that you notice here is that some of these things have awful names like TextBox 184 and TextBox 15 or whatever. When this is export to a data renderer like CSV, you really want good field names. So be sure to set those. And then you can see you have a lot of sparseness here because of all that grouping. So that's not what you want. I'll show you how to fix that. You can set the text box names in tables. If you set those will automatically, by default, be used as the name of the headings in CSV and the name of the fields in any data renderer. Also, if you have charts and you have group names, those can turn up in the data rendered output as well, so set good group names. You can control the output with this data element output property. By default, it's set to auto. It takes into account certain things like whether the thing is visible or not in the report and whether it should output it. But if you want to take explicit control, regardless of anything else, if you set it to output, it will be in the data rendered output. If you set it to no output, it will always be hidden. Probably want to turn off output for redundant visuals like the data bars and the spark lines. You have the text box beside it anyways, so turn those off for output to CSV. You can also add columns that are the opposite. They don't show up in the report when you render the report, but they show up in the data rendered output as raw data. The way you do that is you add a hidden column, and then you just turn on the data element output to output. So they're hidden for a layout renderer, but they are output for a data renderer. And then you'll get something like this, which looks a lot nicer. There's also export to an actual Excel file, not export to CSV. That's not really a data dump anymore. It's actually doing layout rendering. It will have all the formatting and stuff in your Excel workbook. One of the tricks is you can add, when you have page breaks in your report, explicit page breaks, those end up being worksheet breaks in Excel. For each page break, you get a new worksheet in Excel. You can name the worksheets by naming the page in the report. So you can set a page name. The other thing is, in SQL Server 2008 R2 and later, you can say that something is conditionally visible depending on what the current render format is. So it could show up in HTML and not show up in Excel, or vice versa. And the way you can do that is with this expression property called renderFormat.name, and you can check whether it starts with Excel. The reason why I say starts with Excel is because there's an old Excel renderer and there's a new one, but they both start with the word Excel, so better to say it starts with. Okay. So to do that, just show you the output to Excel. And here, for example, you've got something like, what's the name of this text box? Text box 159. That's what's going to show up in our CSV. So, name it something better like % harvested or something. Here you've got a data bar. If I go and open the properties window, the data bar, its data element output is set to auto. Set it to no output so that it doesn't show up in the report or in the exported report. And then you'll get something more like this. If you do all that, you'll get a nice output to CSV like this. The trick that I was showing you about exporting to the rich Excel export, and if you wanted to do something conditional, let's say we insert a column here to the right. We could say that this column is just put, it doesn't matter what I put in here. I could say this column is visibility, show or hide it based on an expression, and in the expression, I'm going to say hide it if render format dot name starts with Excel. Sorry, that should have been globals, bang, render format name starts with Excel. I want to hide it if it's not Excel. So now, when I render this here, I should not see that column. I should see an error. I wasn't expecting that. Not sure why that happened, but anyways, you get the point. So that's it. I have no more tricks that I wanted to show you. Those were all the ones that I wanted to show you. I have 4 minutes left, so if you guys have any questions, I can show those. We can take some questions. This is what we went over today. So using a tablix to organize data. It's really important that you understand the tablix and how that works. Using graphics and colors, richer data visualizations, knowing when to choose one visual over another, and then a bunch of other miscellaneous tricks. Hopefully, you guys got something out of this session and you got somewhere towards the objective, which is being able to design reports that really make the insights pop off the screen rather than making your users go and search for them. Some related content. This one was actually earlier this morning, so the slide deck is from yesterday. So, other resources, definitely you can check out the SQL Server Twitter feed. You can get an eval copy of SQL Server 2012 to try out all this stuff. You can download Report Builder 3.0 for free. So as a web download. So you can use that as well. Other resources, all the docs, all the documentation for Report Builder and Report Designer on MSDN and TechNet. So go and check those out. Yesterday, when I got to this slide, there we go. When I got to this slide yesterday, I boldly predicted that Italy would beat Germany. They did. So at this point, I would just like to gloat that I was right. And now I will push my luck and say that they'll beat Spain. I would encourage you to fill out an evaluation. We want to make these sessions as good as we can and improve on them all the time. So you can scan that with your mobile device, or you can just go to the My TechEd website and do it later. But please do it and give us your comments. Thanks. That's everything.